Good afternoon, dear students. So today we will discuss congruency of triangles. Uh, Before I proceed further, I just want to confirm that you are able to hear my voice very clearly and able to view the screen properly.
Yes, sir.
Okay.
Yes, sir.
Yeah, great. Thanks for the confirmation. Okay. So, what is congruency? Okay. You know, two figures or objects are said to be congruent if they have the same shape and size, or if one has the same shape and size as the mirror image of the other. Let me give you a practical example. You take two 5 rupee coin. Okay, if you take two 5 rupee coin of the similar type, exactly 5 rupee coin, then you will see that they have that exact shape and size. Okay. Another example what I can give is that you know generally you when you take the passport size of photograph. Okay, the two copies of your passport size of photograph is the same size. Okay, and they are identical. Okay, similarly, if you take two bangles of the same size, two ATM cards issued by the same bank are identical. Okay, so these figures are called congruent figures. What is mean by the term congruent? Congruent means equal in all respects or figures whose shapes and sizes are same. I repeat, congruent means equal in all respects of figures whose shapes and sizes are both the same. For example, you know, if you see that, uh, first let me give you the definition. So as you see, dear students, the definition, what I mentioned here, the two figures or objects are congruent if they have the same shape and size, or if one has the same shape and size as the mirror image of the other. Okay, so if you look into the two figures, what I'm just going to show you now, you know these two figures, as you see, they are congruent to each other. These are the two squares, they are congruent to each other. Okay, now similarly, if you see that two as I said, two coin of the same denomination are congruent to each other. Okay, now you may think that why we should study congruence. Okay, so the point is that the study of congruency is important. Let me give an example. You all must have seen the ice tray in your refrigerator, right? Observe that the molds for making ice are all congruent. The cast used for molding in the tray is also has congruent, depressions. Okay, what does it mean? It means that they're all are rectangular, or all circular, or all triangular like that. So whether identical objects has to be wherever identical objects has to be produced, the concept of congruence is used in making the cast. Okay. For example, when it is a publishing of a book, the dimension of the book, each of the pages, thickness, shape and size has to be equal across all the copies of the books. So there the concept of congruency is actually applied. Okay. So now the point is about congruency is that in more mathematical terms, okay, two sets of points are called congruent if and only if one can be transformed to the other by an isometry. Okay, so what is isometry? Let me explain you. Let me first show you the materials first, and then let me show you what is meant by the isometry. Dear students, if you see, in more math, as I am saying, is that in more mathematical terms, two sets of points are called congruent if, that is, if and only if one can be transformed into the other by an isometry. So what is isometry? Isometry is a combination of the following. The first one, a translation that moves every point at a constant distance in a specified direction. Second one, a rotation that moves an object around a center or point of rotation. And third one, a reflection that maps an object from a Euclidean space to itself. Okay, these are more formal way of defining that when the two sets are congruent. Now, the point is that uh, either object can be repositioned and reflected, but not resized, so as to coincide precisely with the other object. As I was telling, you take one 1 rupee coin and another 1 rupee coin of the same currency, and then you see that their shapes are same. They can be, one can be reflected by the other, but they cannot be resized. So two distinct plane figures on a piece of paper are congruent if we can cut them out and they match up completely by means of the translation and rotation. Okay, so let me give you some example, then it will be more clear to you, based on that, whatever I defined about that isometry. So let me first give you some example, but before giving the example, let me make this statement and read it out. So as you understood that isometry is a combination of a translation, a rotation, and reflection. So which means that either object can be repositioned and reflected, but not resized, so as to coincide precisely with the other object. So two distinct plane figures on a piece of paper are congruent if we can cut them out and then match them up completely by means of translation and rotation. Let us take some example, practical example. Two line segments, when we can say that two line segments are congruent, dear students. If you see that two line segments are said to be congruent, you see, the two line segments are congruent if they have the same length. See the following diagram, as you see. These two line segments have the same length. Now, if you consider the first, line segment, that first line segment, if you say, and the second one, suppose this is the first one, and this is the, second one. If you see that, the second one is actually obtained from the first one by means of either translation or rotation, right? So from first one is in horizontal, then you make an little bit of rotation and you get this one, second one. But what is the condition of the two line segments are to be congruent? If they have the same length. That is the only condition to have two line segments are congruent. At the beginning, I said, dear students, that we will be studying congruency of triangles. But before that, I just want to say that, okay, what congruency means for the other kind of, shapes. For example, okay, when we can say that two circles are congruent, we say two circles are congruent if they have the same diameter. Okay, so let me show you by means of this, diagram. I hope you understood by now that how it looks like when two circles having the same diameter. Okay, for example, if you look into these two circles, I'm just going to place it in front of you. Yes, if you see, dear students, these two circles are congruent to each other. In fact, as I was telling few minutes back, if you see the first, if you consider the first, object, the first circle is a, suppose a 5 rupee coin, and second one is also a 5 rupee coin. They have the same shape, right? Exactly same shape and same size. That means if you take that second coin and put it on top of the one and look from the outside and see that as if it is only one coin is there. Correct. Now, so we discuss about the congruency of how two line segments are congruent, how two circles are congruent. Now, dear students, I want to show you that how when we can say that two angles are congruent. Okay, so when we can say that two angles are congruent, so here it is. Dear students, that two angles are congruent if they have the same measure. If you look into the adjoining diagram, you see that that angle one in the first one. Let me show you. This is the first angle, and this is the second angle. You see that the two lines and the vertex, they have a different positions, but if you see that measurement of these two angles are exactly same. That means if we take the first angle measurement is 60 degree, then the second angle measurement should also be 60 degree. So I'm just recapping that when we say that two line segments are congruent, two line segments are congruent when they have the same length. Okay, if they have the same length, then we can say that two line segments are congruent. Two circles are congruent if they have the same diameter. Okay, two angles are congruent if they have the same measure. Okay, so these are the three different conditions you see that what is required to be congruent, which required to satisfy the congruency, and it depends on the kind of objects we are dealing with, whether two line segments, two circles, or two angles. In the similar manner, dear students, two polygons, when we can say two polygons are congruent. Okay, and that is a very important topic. When two polygons we can say congruent, let me show you the diagram first and the statement, and then let me explain you in details. Now, if you see in the adjoining diagram, dear students, there are two polygons, and both the polygons are congruent. Means actually, if you take one polygon and you put on top of the other with the proper orientation, then as if you will see it is a one polygon. Now, if you see the first polygon, dear students, okay, that first polygon, and from the first polygon, if you make little bit of rotation and translation, you get the second polygon. You take the first polygon, this is the first position of the polygon, and then you take a little bit of translation and rotation, you get the second one. So the two polygons are congruent if they have equal number of sides, suppose n, okay, and have numerically identical sequence, even if clockwise for one polygon and counterclockwise for the other. That is side angle for n sides and n angles. If you look into the diagram as I just explained, these two are congruent polygons. Now, dear students, we are slowly moving our discussion to the congruency of triangles, because triangle is also a polygon, right? Now, the point is that triangle is a very important discussion as long as the congruency is concerned. So, when we can say that two triangles are congruent, okay, so let me first show you that when we say that two triangles are congruent. So, dear students, if you look into that, the adjoining diagram and let me tell you the statement what I wrote is that two triangles are congruent if and only if their corresponding sides are equal in length and their corresponding angles are equal in size. What does it mean? It means is that, you know, suppose I give the name of this triangle as ABC. A, B, C. And the other one I see is that D, E, and F. If you look it minutely, dear students, that the length of the side AB is actually equal to the length of the side DE. Okay, AB is equal to DE. Length of the side BC is actually equal to the length of the side EF, and length of the side CA is equal to the length of the side FD. So now three sides are equal and three angles are also has to be equal. So that means whatever you see the angle A should be equal to the angle D. What you see the measurement of the angle B should be equal to the measurement of the angle E, and you see the measurement of the angle C is equal to measurement of the angle F. So dear students, as you see that these two triangles are said to be congruent. Why they said to be congruent? Because their corresponding sides are equal in length. That means what? The moment I say that corresponding sides are equal in length, the corresponding, what we say is that corresponding sides are equal in length. That means what? That means AB is equal to DE and BC is equal to EF and CA is equal to FD, and their corresponding angles are equal in size, and their corresponding angles are equal in size. That means what? Whatever angle A you see, dear students, is actually equal to the measurement of the angle D. Whatever you see the value of the angle B, that is equal to angle value of the angle E, and same thing for angle C is equal to angle F. Now we can say these two triangles ABC and DEF are congruent to each other. Now how we are going to write them? When they are congruent, how we are going to write them? That is very, very important. Okay, very important. The sequence is also very important. So how we are going to do this thing is something like this. Okay, if the triangle ABC is congruent to the angle DEF, the relationship is written mathematically as that triangle ABC is congruent to that equal, and there is a then tilde that above this, that is actually called the sign of congruency. That is called the sign of congruency DEF. But one very important point I'm going to tell you, dear students, and remember it very carefully, and you need to apply these concepts very well. Whenever I say the triangle ABC is congruent to, this is the sign of congruency, is congruent to the triangle DEF. That means what? Very important. I'm going to use a different color. That angle A should be correspond to the angle D. That means angle A and angle D are equal. So in the triangle ABC, it starts with A. So in the triangle DEF, it has to start with D. Similarly, angle B should be equal to the angle E. Okay. and angle C has to be equal to the angle F. Always do this sequence. What does it mean? Let me take two triangles and let me spend some time here because this is very important. Suppose you have two triangles and one triangle is, triangle PQR, and the another triangle is that triangle, uh, XYZ. And you see, when you are seeing those two triangles, you see that angle P is actually equal to angle Z. Okay, angle P is equal to angle Z. And you see angle Q is equal to angle X. And angle R is equal to angle Y. Then how we are going to write the congruency mathematically? If you write the triangle that PQR, if you write the triangle here is PQR, that congruency should be P is correspond to whom? P is correspond to Z.
ZXY.
Z, X, Y. Very well said. Thank you. So you should write Z, X, Y. Often I have observed that students actually write X, Y, Z. No.
Sir, I didn't understand this.
Okay. Thanks for asking this question. What I'm saying is that when you write that congruency, mathematically, you need to write the exact sequence they are matching. Suppose we have two triangles, as I was saying. Suppose we have two triangles, triangle PQR and triangle XYZ. And when we observe these two triangles, we observe that we conclude that angle P in the triangle PQR is equal to the angle Z in the triangle XYZ. Angle Q in the triangle PQR is equal to angle X in the triangle XYZ. And angle R in the triangle PQR is equal to angle Y in the triangle XYZ. Then, how we are going to write the congruency? We'll write that if we write the left-hand side PQR, then P corresponds to which triangle, P equal to which angle of the triangle?
Yes, sir.
Got it, right? P
Yes,
is correspond to Z. But I want to spend some time here because this is very important. P is correspond to Z. Okay, so that's why if you write P, then you should write Z in the left-hand side, right-hand side. In the middle, if you write Q, then you should write X in the middle. Okay. If you write R in the third sequence, then you should write Y here. Or suppose I want to write the triangle in different manner, dear students. Suppose I want to write the left-hand triangle, I want to write is that, QPR. Then how I should change it? Q correspond to whom? X, correct now? So X. P correspond to what? Z.
ZY.
X, Z, Y, correct. R correspond to Y. Remember always this thing. Never mix up. Do not write the way. Yes, writing PQR and QPR, it represents both represent the same triangle. But the sequence of writing is important as long as the congruency is concerned. Because from here, what you conclude, dear students, the moment you write QPR is congruent to X, Z, Y, from here I can conclude not only angles, I can conclude about their, the different, sides also. So from there we can conclude that length of the side QP is equal to XZ. Got it? Then PR is equal to ZY and QR is equal to XY. Got my point, dear students? As it is QP the first two, it should be the XZ of first two. Got it?
Yes, sir.
Okay.
Yes, sir.
Then if we take the PR of the, the second and third of the first triangle, then I took the Z and Y, that second and third of the right hand side triangle. If we take that, that QR, that is first and third of the first triangle, then I should take the first and third of the right second triangle in the right hand side xy. That is very important. Always remember this thing, because the moment you write that congruency of two triangles, the other people can infer a lot of things from there. What is this? Let me tell you once more. Okay, why I'm telling repeatedly this thing, because this is the one soft corner I have seen, that where students actually take it for granted and write in the any sequence, and I do not want you to do the same thing. So before I proceed further, I just want to say one more thing. Okay, suppose we have someone is telling you, hey, I have two triangles. One triangle is, LMN, and the other triangle is, triangle, what we can say is that, PQR. These two triangles are congruent. The moment this information is given to you, there are 6 characteristics of a triangle. What are those 6 characteristics? There are 3 sides and 3 angles. So you can conclude about what are the 3 sides of the triangle LMN is equal to the 3 sides of the triangle PQR. Very clearly you can conclude that thing. This implies what? The moment you get this thing, this implies LM is equal to PQ. LM is equal to PQ. Then MN is equal to QR. And LN is equal to PR. And you can also conclude that angle L is equal to angle P. Angle M is equal to angle Q. And angle N is equal to angle R. Now, if you write that sequence in different manner, the person who is actually making some conclusion from that congruency will make a different conclusion. So maintaining a proper sequence while doing congruency is very, very important. Okay, now let me proceed further, dear students. The next point what I'm going to discuss now, dear students, is that from the fundamental concepts, we understood that to determine the congruency of triangles, we need 6 parts to compare. So 3 pairs of sides and 3 pairs of angles. Correct? There are 6 components or 6 parts, the way you want to define. Okay, any triangle there are 6 parts. Okay, the 6 parts is the 3 sides and 3 angles. Okay, so those 3 sides and these 3 angles has to be exactly equal, so that we can conclude that these 2 triangles are congruent. However, it is sufficient to establish the equality of 3 corresponding parts and use one of the following results to deduce the congruency of 2 triangles. What does it mean? As long as the triangle is concerned, dear students, it is not important that you need to measure all these 6 parts individually. Rather than, out of these 6 parts, you can take only 3 parts and conclude whether the triangles are congruent, these 2 triangles are congruent or not. So what is that? Let me first tell you the statement. Write you the statement, whatever I just said. So, and here it is. And as you see, dear students, that so we see from the above fundamental theory, to determine the congruency of triangles, we need 6 parts to compare, 3 parts of sides and 3 parts of angles. However, it is sufficient to establish the equality of 3 corresponding parts and use one of the following results to deduce the congruency of 2 triangles. And I am going to discuss those topics. The first one, dear students, that is called Sss Congruency Rule. The first one is called the Sss Congruency Rule. Very important, and listen very carefully. Any smallest question, never hesitate to ask me about it. The first one is called the side, side, side. Okay, what does it mean by side, side, side? Let's understand first, and then I will, uh, ask. I will take any questions you have. If three pairs of sides of the two triangles are equal in length, then the triangles are congruent. You look into this one. The two triangles are there. One is ABC, the other one is DEF. What we see is that AB is equal to DE, BC is equal to DF, and CA is equal to EF. Then what we can conclude, dear students? We can conclude, without measuring the angles, we can conclude that these two triangles are congruent. So a minute back I said there are 6 parts, 3 angles and 3 sides. Now just by measuring the 3 pairs of sides, we are concluding that these two triangles are congruent to each other. We no need to explore whether the angles are equal or not. They have to be equal. If the sides are equal, then corresponding sides are equal, then the corresponding angles has to be equal for a triangle. So then what we can conclude? The symbolic representation, what we can write? If we write the triangle left hand side as ABC, then what we are going to write is that congruent to, what is A is congruent to? It is D. Okay, and B is congruent to E. Okay, and C is congruent to F. So I will write DEF. Correct? So this is called the side, side, side congruent rule. I hope you got a very clear idea, dear students. So before I proceed further, just tell you that why SSS is important. Because in SSS, you no need to measure the 3 angles to determine whether the 2 triangles are congruent or not. Just if you find that corresponding pair of sides are equal in length, you can just conclude, yes, these 2 triangles are congruent to each other. Now, dear students, the next part of discussion is that side, angle, side. Very important again. Okay, so let me explain you what is meant by side, angle, side, and then I'll take questions if you have any. So, dear students, if you see the side, angle, side congruency is something like this, that remember that sequence, side, angle, side, that whenever I say that SAS, this sequence is important. That means 2 sides and an angle in between them. So this is a side. A stands for side, A stands for side, and in between them there is an angle. Correct? So that is why it is called SAS, or side, angle, side, as it is written here. So what is that SAS rule? If 2 pairs of sides of 2 triangles are equal in length and the included angle are equal in measurement. That means if you take in these 2 triangles, dear students, that ABC and the triangle ABC and DEF, what we see that AB that AB is equal to DE, this one. So this AB is equal to DE and BC is equal to DF. Okay, AB is equal to DE. So this one. So this length AB is equal to DE, and BC is equal to, BC is this one, is equal to DF. Now these 2 sides, and what is the included angle between them? It is this angle, that is ABC for the first triangle and EDF for the second triangle. So if now let me revisit the statements once more. If 2 pairs of sides of 2 triangles are equal in length and the included angle are equal in measurement, you must take that included angle, dear students. Okay, that is very important. Okay, then these 2 triangles are congruent. Let me explain once more if you have any doubts so that you can ask me. So let me use a different color. So suppose we have a triangle like this and another triangle like this. Okay, as these triangles are not up to the scale, whatever I am drawing now, so consider these two triangles are congruent. So if we consider, suppose I give these triangles as P, Q, R and X, Y, Z. Now if we take that side PQ, if we see that PQ is equal to XY and PR is equal to XZ, then we should take that included angle of PQ and PR, not the other angle. And similarly, included angle of XY and XZ, that is this one, YXZ. Then we can say that these two triangles are congruent under SAS. Why it is important? Because out of the 6 parts, that is 3 sides and 3 angles, you don't need to spend time in measuring the 6 parts. Rather, you just measure the 3 parts, that is the 2 sides and included angle. And if you find they're equal, you can just say, yes, these two triangles are congruent to each other. I hope it is clear, dear students. Now the next point what we are going to discuss, dear students, is that the next rule of congruency is called ASA Congruency Rule. Okay, and I am going to show you what is ASA congruency. So, so let me write down the statement first, and then let me explain further. So dear students, what is angle side angle? And the sequence, like the previous one, here the sequence is also very important. Okay, so here you see that 2 angles, okay, and a side in between them. That is why it is called angle side angle. That means we are going to consider that side which is in between 2 angles under consideration. And what it says, dear students, that ASA congruency, if 2 pairs of angles of 2 triangles are equal in measurement and the included side are equal in length, then the triangles are congruent. If you look into these two triangles, what you see, that this angle, if you see, the angle ABC is equal to angle EDF, and the angle BAC, okay, this is the angle BAC, is equal to the angle DEF, okay. Then what the side we are going to consider, the between these 2 angles, that is, if you consider the triangle ABC, between these 2 angles, that is ABC and BAC, the side is this one. And for the triangle DEF, what we see, between the angles EDF and DEF, the side is this one. If these 2 sides are equal in length, you can say these 2 triangles are congruent under ASA rule. Now, here also, we are not spending time to measure the 6 parts. Just by measuring the 3 parts, we are able to conclude it. So now, one thing, when I say that when you find a pair of angles of 2 triangles are equal in measurement and the included side are equal in length, then those 2 triangles are congruent under ASA. That means what? It is not congruent under SSS. Yes, they are also congruent under SSS. But we didn't measure with respect to the sides. Here we are congruent means congruence. Okay, whether it is SSS or SAS or ASA, and other few other also you learn as time goes by. But the thing is that whatever the limited information we have, okay, with that information we are concluding whether these two triangles are congruent or not. When we are discussing about ASA, we do not have the measurement of the three sides of both the triangles. What we have? We have the measurement of the two pair of angles and a side which is included between them. And with this, that's what I am calling it as a limited information. With this limited information, we are concluding they are congruent. But if you see these two triangles, they are, all the angles are equal, all the sides are equal. Means what you can conclude? You can conclude definitely the angle C, the angle C has to be equal to the measurement of the angle F, 100%. That has to be. And the other two corresponding sides also has to be equal in length. Is it absolutely clear, dear students? Any doubt you have so far? It's clear? Could you please confirm that it's absolutely clear?
Yes, sir.
Yes,
Oh,
sir.
great. Now, the next point what we are going to discuss is called the AAS, that is angle side congruency. And what is that? Let me first show you the diagram, the statement, and then I will explain you further. What is AAS? Here also the sequence is very important. Okay, let me explain you that what is meant by AAS, that is angle side. If two pairs of angles of two triangles are equal in measurement and a pair of corresponding non-included sides are equal in length. I repeat, if two pairs of angles of two triangles are equal in measurement and a pair of corresponding non-included sides are equal in length, then the triangles are congruent. Let's take that adjoining diagram. If you look into these two triangles, that is ABC and DEF, what you see, dear students, is that for the triangle ABC, the angle ABC is equal to the angle EDF. Okay, angle EDF. And the angle BAC, that is the angle BAC, is equal to the angle, DEF, that is DEF, that angle. And what we see is that CA is what? CA is the side which is not included between these two angles, dear students. If you look into the triangle ABC, what are the two angles we are considering for the triangle ABC? One angle is ABC and the other angle is that BAC. Now, what is the side AC? AC is a side, this one, which is not included between these two angles. Similarly, for the other triangle DEF, what are the two angles we are considering here? One is that EDF and the other one is that DEF. And the side EF is not included between these two angles. Now, if these two sides which are not included between these two angles under consideration are equal, then we can say these two triangles are congruent to each other. So that is why it is called angle. That means you are taking two angles first, angle, and a side which is not included between them. Unlike the other one, angle side angle. Angle side angle means is that you are taking the side which is between these two angles. But here angle side means you are taking two angles and a side which is not included between them. Let me read the statements once more, dear students, before proceeding for the next rule. That AAS, that is angle side, tells that if two pairs of angles of two triangles are equal in measurement, if two pairs of angles of two triangles are equal in measurement and a pair of corresponding non-included sides are equal in length, then the triangles are congruent. I hope it is clear, dear students, very well about that angle side congruency. Now the next rule of congruency, what we are going to do, dear students, is called the, a right angle hypotenuse side, that is called RHS, and we are going to discuss about that RHS congruency now. Okay, what is RH congruency? So let me show you first. Okay, let me show you the diagram and the statement, and then we will discuss about the discuss further, and please feel free to ask question if you have any. Never hesitate to ask question. So what is RHS congruency? Dear students, the moment it is RHS congruency, always remember it is dealing with then a right angle triangle. Okay, right angle, RH, right angle and hypotenuse side. Okay, RHS, so that is right, H is hypotenuse, and then S is side. That is why it is called RHS. Right angle, right, from right angle we take the letter R, from hypotenuse you take the letter H, and from the side we take the letter S. What does it mean? It means is that if two right angle triangles have their hypotenuse equal, okay, I repeat, if two right angle triangles have their hypotenuse equal in length and a pair of shorter side are equal in length, then the corresponding two triangles under consideration are congruent. If you see the the adjoining diagram, here we have two right angle triangles. Anyone asking any question, dear students?
Any of the shorter sides, any of the sides, right?
Any of the sides. Yes, exactly. That is why I said a pair of shorter side. Why shorter side? Because in a right angle triangle, dear students, hypotenuse is the largest one, right? So apart from the hypotenuse, the other two sides, any two pair can be equal. Got it? So now let me discuss with this example that if you consider these two triangles ABC and DEF, you see that BC is the hypotenuse for the first right angle triangle, and EF is the hypotenuse of the other one. So if hypotenuse has to be equal, that is for sure. Okay, hypotenuse has to be equal. Right angle to you already know that it is 90 degree, they are equal to each other. And then we see that if AC is equal to FD, that AC is equal to FD, okay, then we can say these two triangles are congruent to each other. It may possible you have AC, you have this information that AC equal to FD, but instead of that, if you have the information that okay, AB is equal to D, then also you can say. And obviously when they are congruent, you can conclude that AB is equal to DE. So what I wanted to say, dear students, is that in right angle hypotenuse congruency, the two right angles have their hypotenuse equal in length and the pair of shorter sides are equal in length, then the triangles are congruent. And whenever two triangles are congruent, then you can take some decision about the other sides. Then you can say what? Then you can say that AB must be equal to DE. From the information that BC is equal to EF and AC is equal to FD, we are concluding that these two right angle triangles are congruent. Once you know these two right angle triangles are congruent, then definitely what you can say is that angle C is definitely is equal to angle F. That is the conclusion you are making from the congruency. First you are establishing they are congruent with this limited information. Now the moment that establishment is done, that is the two triangles are congruent, then you can conclude, you can take some information out of it. That is angle C is equal to angle F. You can say that angle B is equal to angle E. Those information were not given to you, but you are concluding this information because these two triangles are congruent to each other, and that is one purpose of learning congruency. When you will solve problem, then you will see that once we establish congruency of two triangles with this limited information, that means two pairs and one side or something, and whatever the topics we have discussed, not having all the six parts, that is three sides and three angles, we are having just only with limited information under this rule. Once you establish that congruency, then you can conclude the other parts, they are also corresponding parts are equal, corresponding angles are also equal in measurement. That is why is congruency is very important, so that you can make some conclusion out of it, you can get some information out of it once your congruency is established. Okay, dear students, now so have a quick recap before we proceed further. If I give you a quick recap, dear students, is that about the congruency, I just want to say few things, is that whatever we have learned so far before we proceed further. So first we understood what is congruency, then we understood that side, also known as SSS congruency. After that, we observed that SAS congruency, that is side angle side congruency. Then we understood about ASA congruency, that is angle side angle congruency. Then we discussed about AAS congruency, that is angle angle side congruency. And then we discuss about RHS, that is right angle hypotenuse side congruency. Now, the point is that what we left with, dear students, is that what is called that SSA, that is side angle, or ASS, angle side. Okay. Now we are going to discuss about that. What about that side angle congruency or angle side congruency? Okay. What means is that when specific of two sides and a non-included angle is given, can we discuss? Can we say they are congruent? Not always. Okay, let me show you by means of an example. Okay, let me show you that by means of an example that why that SSA or ASS doesn't always guarantee you that the two triangles are congruent. Okay, and I'm going to take you to the next page to explain you further very important information, and just have a look into it, dear students. So what is our point of discussion now? That is called SSA or ASS, which specifies that two sides and a non-included angle does not by itself prove congruency. In other words, to show congruency under SSA or ASS rule, one additional information is required. And what is that additional information? Like the measurement of the angle under consideration. Whatever the angle we are taking now, dear students, that is also very important to take a measurement. Okay, what is that? If that angle is under consideration is less than 90 degree, then we can say that SSA or ASS rule will not be able to prove the congruency of two triangles. Okay, how? Let me show you, and let us discuss this thing in details. Okay, so please concentrate and about these two diagrams and listen to my explanation very thoroughly. It's very important. So not all books actually explain in these details about why under SSA or ASS you cannot prove the congruency always. You look into these two triangles, dear students. One is at ABC, and the same triangle I have written in the right hand side ABC. Now what are the two sides we are considering? One side we are considering is AB. This AB is equal to this AB, dear students. And this AC is actually, this AC we are considering with this AC, correct? And a angle which is not included between these two sides is this one, angle B, and here also angle B, correct? Now what we are doing, dear students, is that in the initial position, what we see is that AB is equal to AB and AC is equal to AC, correct? And you have that angle B here and angle B in the both there. Now, if you see both the triangles are congruent, ABC, ABC, because it's the same triangle now. Now, what we are doing is that we, from the point A, we draw a perpendicular to the line BC and we get the foot of the perpendicular is D. Okay, so that means D is on BC. After that, what we have done, dear students, is that we take that AC length and we start moving in this direction. That the point C is moving like this, and we come to a point called C dash here, such that DC is equal to DC dash. Then the new position of AC will be what? AC dash. So what you see that AC is nothing but AC dash, both are the same length. Now what are the two triangles you got? Left hand side you got ABC and right hand side you got ABC dash. Okay, and in both these triangles ABC and ABC dash, what you see? You see that AB is equal to AB. AB of the left hand triangle is equal to AB of the right side triangle. Then AC in the left side triangle is equal to AC dash of the right side triangle, and angle B, or I can write ABC of the left side triangle, is equal to angle AB C dash of the right side triangle. But it looks like that those two triangles ABC and ABC dash are congruent? No. How? Just by look and feel, you see that these two triangles are not congruent. They are not of the same size. Correct, no? So what we see is that in this one, that SSA or ASS cannot always guarantee you that these two triangles are congruent or not. Okay, dear students, so let me explain, whatever I have explained, let me, show you by means of this, the written statement, which I take it from the study material. Okay, so here I'm going to write the statement and also one round of discussion after that. So I hope all of you are able to view this statement, dear students. Yeah.
Yes, sir.
Yeah. So if you see in this diagram, first we see that the triangle ABC is congruent to itself by means of SSA rule. We know that SSA rule allows us to congruency. Okay, it's by means of SSA rule. Now AB is equal to AB, AC is equal to AC, and CBA is equal to CBA. Now let us move the point C. As you see, whatever I said a few minutes back, now let us move the point C towards the point B along the line CB to get a new point C dash such that AC is equal to AC dash. And the position of the point C dash can be found by means of the following construction and steps. Step 1, draw a perpendicular from the point A to the line segment BC and let D be the foot of the perpendicular. Step 2 is that measure the distance CD. And step 3 is that move the point C towards the point B along the line CB to a distance 2 into CD from the point C and name the new position as C dash. So what we observe is that CD is equal to DC dash. Now if you look into the two triangles, ABC and ABC dash, we observe that AB is equal to AB, AC is equal to AC dash, and angle CBA is equal to angle C dash BA. So according to the SSA rule or ASS rule, both the triangles ABC and ABC dash should be congruent to each other. Because we took that, okay, let's assume they are congruent to each other. Then they must be congruent to each other. Correct or not? But so this is the statement what I'm making here. that, okay, let me put the statement here in the below actually. Yeah. Okay. Now, for the two triangles that ABC, two triangles, one is ABC and the other one is at ABC dash, we observe that AB is equal to AB. So if you if the diagram is not visible, I can keep the diagram here so that you can you can go through it, and while you can make a proper understanding while go through the statement. Now for the two triangles ABC and ABC dash, we observe that AB is equal to AB, AC is equal to AC dash, and angle CBA is equal to angle C dash BA. So if we consider that SSA rule guarantees congruency, then SSA rule is actually meeting here. AB is equal to AB, AC equal to AC dash. These two sides are equal, and a non-included angle, that is CBA of the left-hand side triangle and C dash BA of the right side triangle are meeting each other. That means what? What we can say, dear students, here is that AB is equal to AB, AC is equal to AC dash, and angle CBA is equal to angle C dash BA. So what you can conclude under SSA rule, they are congruent. Okay. But in reality, we see that it is not possible, as the shape and sizes of these two triangles ABC and ABC dash are differing. So, what I said in the beginning, that whether SSA rule will guarantee congruency or not, it depends on what is the measurement of the angle B. And here is the conclusion, dear students. If the angle under consideration is greater than 90 degree, that means in this case the angle B. I repeat, if the angle under consideration is greater than 90 degree, then SSA or ASS rule is able to prove the congruency of two triangles. And if the angle under consideration is equal to 90 degree, then SSA or ASS rule is able to prove the congruency of two triangles. In fact, in this case, the rule reduces to RHS. But if the angle under consideration is less than 90 degree, which is the case here, you see that angle B is less than 90 degree now. So what we can say? We can say that no, these two triangles are not congruent. So that means what? What we can say is that if there is very important observation. If the angle under consideration is greater than 90 degree, it is congruent. We can prove congruency under SSA. If the angle under consideration is equal to 90 degree, then also we can prove it is congruent, but more specifically you can say it is congruent under RHS congruent rule. But if the angle under consideration is less than 90 degree, okay, as I show here this statement, dear students, if the angle under consideration is less than 90 degree, then SSA or ASS, rule will not be able to prove the congruency of two triangles, as I showed you in the in the explanation what I did with the by taking the two triangles, right? So this is a very important observation under SSA or ASS. So dear students, henceforth, if any question asked that whether SSA or ASS is going to prove the congruency or not, then your answer should be, it depends. It depends on the measurement of the angle under consideration. If the measurement of the angle under consideration is more than 90 degree or equal to 90 degree, then SSA or ASS can guarantee congruency. But if the measurement of the angle under consideration is less than 90 degree, then we cannot confirm that the two triangles are congruent under SSA or ASS rule. Now what is left, dear students? The another thing left is that what is called angle congruency. But angle congruency is not possible. Okay, let me show you by means of an angle. Okay, If you say, let me first, show you this particular statement and then explain you. Angle does not provide information regarding the sides of the two triangles and hence, does not prove congruency. How? You consider that, there are, you considered, two, equilateral triangle. Okay. If you consider two equilateral triangles, dear students, if you see that equilateral triangles, they are, all the sides are equal and all the angles are equal, but they can be of different shapes now. But all the angles are 60, 60, 60 now. For example, if I have, suppose this is an equilateral triangle, please consider this as an equilateral triangle, and this is also an equilateral triangle. In both the cases, the angles are all 60 degrees. But do you see that smaller triangle and the larger triangle, they are congruent to each other? No, because they are not of the same shape and same size. So angle does not provide information regarding the sides of the two triangles. Hence, they do not prove the congruency. So dear students, with this, I would like to conclude the class for today. And in the next class, we will do some practice related to congruency. And is so far everything is clear, dear students? You understood each and every point very clearly. Can I get a confirmation from each one of you, dear students?
Yes, sir.
Yes.
Now, what I will do after this class, I will share that recorded lecture. You can also go through this recorded lecture once, maybe after a couple of hours, so that everything will again, get repeated and you will have a very clear understanding. And in the next class, we will make more practice from it. Okay, dear students.